Being able to automatically move and copy data is very useful, but at some point human intervention in the plan is required. For this, an interface between the info provider and the user is required. The input-ready query performs that function by providing the user with a point of entry for planning data. We will create several input-ready queries during the course of these lectures. We will go through the settings step by step for the first query, and the layout and the settings of the rest of the queries will be provided at the end of the relevant chapters. The first query we will build will be to enter price data. Recall that we have no actual data on which to base our prices, which in the real-world applications are unlikely. But it provides a useful way to demonstrate the initial entry of data. From the requirements, we have the following statement. Prices can only be planned on a higher level. For example, we cannot plan prices on material customer level, only material group and customer. In some instances, we may have prices applying to a material within a material group, while material group and customer-specific prices may exist. Planned prices are also valid for a full year, and no periodic price planning is required. In the design of the price application, 3 choices are presented. Create 2 aggregation levels, one containing material group and the other material group and customer. Build a query for each, or create a single aggregation level containing material group and customer. Build 2 queries where the filter for the material group price contains a hash against customer, and add customer to free characteristics in that query, or create a single aggregation level, single filter, and query, and display all possible combinations of material group and customer, including non-assigned or hash customers. All 3 approaches will provide the same result. There is no hard and fast rule for the correct approach or best practice. The first approach requires more aggregation levels, but the number of filters and queries remain the same. The approach also has a small impact on the configuration of characteristic relationships, but this is not significant enough to justify a change in approach. So which way do we go? My preference is an approach where the filter contains as few hard-coded hash values as possible, and that approach is what we will follow throughout this lecture. The third option is the least attractive to users and from a performance point of view, and should only be followed if a customer has a specific requirement. The steps to create the input-ready queries are as follows. Create 2 aggregation levels. One contains material group and one contains material group and customer. After the creation of the aggregation levels, create 2 filters, one for each aggregation level. And then we create 2 queries, one for each aggregation level containing the filter in step 2. Note the variables are only a recommendation. By having optional values for material group and customer, we can either restrict the values to a selection or display all the values in master data. One important aspect to remember when building an input-ready query is that the full intersection must be addressed. This means that every characteristic must have a unique value in order for the input-ready query to be input-ready and thus save data. Let's look at an example. When looking at the aggregation levels and filters, if we build a query with all the hard-coded values and single mandatory variable values and free characteristics, then we are left with material group, customer, and fiscal year. Each of these characteristics that are not restricted to a single value must be in either rows or columns in order for a key figure to address a unique intersection of values. If we have multiple customers selected and have customer and free characteristics, the key figure does not address a unique material group, fiscal year, and customer combination and will not be input ready. So let's create an input ready query. Input-ready queries are created in Eclipse, and we create them by going to the aggregation level and right-clicking, saying New Query. The query we're going to create is called TRPR1002 Q0001, and it's going to be called Material Group Customer Prices, and finish. The first setting that we need to set is we need to make sure that this query starts in planning mode. So we access the planning tab, expand it, and say query start in input mode. No other settings such as zero suppression, etc. is required at this stage. Next, we're going to select our filter. So we go to the filter tab, and we're going to select the filter we created previously. So our material group customer prices filter and drag that into fixed values. We can now see that the variables that we defined in our filter is also available in our query. Under sheet definitions, we're going to add our characteristics and key figures to rows and columns. So let's start with columns, and we're going to add fiscal year and also the key figure 0 amount. For the key figure 0 amount, we need to make sure that it's planning ready, so it must be able to accept a value. So we're going to change the input ready to make the key figure input ready. In our rows, we're going to add the characteristics customer and material group and add them. And then I also just like to change the results to never. Another important setting is the access type for results values, and there we're going to have to set it to master data, and this will return all the values in customer material as combinations to be input ready. We also need to do the same for fiscal year. So typically when you create the query, it will be as posted values, but we need to change that to master data. And then all the characteristics that are not defined either as hard-coded single values, we need to add, or we can add to free characteristics. So that's for currency key, the fiscal year variant, info provider, sales org version, value type, and access sequence. You can also change them to access type, master data. So once these settings have been made and our key figure is input ready, we can save the query. Now let's look at our query in action. In SAP, we have transaction RSRT, so RSRT, and that is called the query monitor, and we can test our queries in this transaction. So we enter our query TRPR122Q1, just generate for good measure, and then execute. We can now enter our variables, so version 100, value type 20 for fiscal year 2019, and OK. We're now presented with our query, and because we selected master data, all our material groups are combined with all our customers. So we can see we've got 16,000 or 1,600 rows, and we can enter prices and save the values. Now let's illustrate the uniqueness of the intersection. So if, for example, I remove material group to free characteristics, we see that the query is no longer input ready because we do not address the intersection uniquely. Input ready queries are an important part of planning, and it allows users to enter and change plan data directly. We have created 2 input query readies, one for each of the aggregation levels to enable planning of prices on various characteristic combinations. There are a few important pointers to remember when creating an input ready query. The query must be set to start in planning mode. The key figure must be set as input ready. The key figure must address a unique combination of single values in order for the query to be input ready. And setting the result access to master data will allow data entry against new combinations that do not exist in the info provider yet. In the next lecture, we will look at analysis for Office and add the 2 queries to a price planning workbook. Analysis for Office is SAP's